See this question now. We have three concentric shells now. We have three spherical shells which are concentric.
Now that means they have a common center. And then what? They are named like 1, 2, 3. 3 being the largest one, right? And then what? I have the radii. Small letter a is the radius of the innermost sphere. Intermediate sphere has a radius of small letter b. And the outermost sphere has a radius of small letter c. The question is to find out the potentials on the surface of each of these spheres. Potential at the point A, which is a surface point for the innermost sphere. Potential at B, which is the surface point for intermediate sphere. And potential at C is what? C is what? C is a point on the outermost sphere. Okay. Now before getting to this, I'll just revise these equations. We have learned this already. What is the potential due to a spherical shell? Outside point's potential is given by sigma by epsilon 0 into r square by small letter r. What is sigma? Sigma is called surface charge density. Total charge by total area. What is capital letter R? Capital letter R is the radius of the sphere. Small letter r is what? Small letter r is the distance to the concerned point. Okay, right. Similar way, what is potential on the surface of the sphere? Surface of the sphere and inside the sphere are the same. We have seen this already. And it is sigma by epsilon 0 into capital letter R, where R is the radius of the sphere. Okay. Now, I'm going to see the potentials at each of these points, A, B, C. We'll write them one by one. First question is to find out the potentials at A, B, C. So I'll write the potential at A first. Now potential at A has three contributions. From what? V1, V2, V3. What are they? This is actually, this point A is what? That point A is on the surface of innermost sphere, which means it is a surface point for that sphere. But see this sphere and this sphere. This point is actually inside point, right? For both the spheres. So there are three contributions by each sphere here. Understand? One from the first one A, second one from the second one, third one from the third one. Okay. So there are three terms for the potential. So I'm writing one by one. What is the potential equation? This point, I'm looking at A now. A is what? A is surface point for the innermost sphere. What is the potential on the surface? Sigma by epsilon 0 into its radius. So I'm writing it first. Sigma by epsilon 0 into its radius is A. Plus. Then for the sphere, A is what? A is an inside point. Inside point. Inside point it is same as what? Surface point. Which is sigma by epsilon 0 into its radius. Tell me, sigma by epsilon 0 into its radius is B. But it is negative. Why negative? Because in the question it is given that surface charge density is minus sigma. Then there is a third term coming out of potential due to the largest sphere. What is the potential due to the largest sphere? Even for the largest sphere, this point A is what? Inside point, no? So I can write inside point, what is potential? Sigma by epsilon 0 into radius. So sigma by epsilon 0 into C. Okay, so I got three terms now. So I can simplify this. I take sigma by epsilon 0 common. I'll have what? A plus B minus C. This is equation number 1. Potential at A. Potential at A. Okay. So I've done the first part. Similarly, I'm looking at potential at B now. What is potential at B? Potential at B also has three contributions. V1 plus V2 plus V3, no? One each from the three spheres. Right. This point is actually what? This point is outside point for the sphere, surface point for the sphere, and inside point for the sphere. Okay. So I'm taking one by one. So I'm writing the potential due to the sphere, no? At this point. What is the potential? It is an outside point, right? Outside point, what is the equation? Sigma by epsilon 0 into radius square by distance. Radius for the innermost sphere is A square by the distance there is what? Distance to that point is B. So it is B. Plus. Second one, it is sigma, minus sigma. Sigma is minus sigma, right? Minus sigma by epsilon 0 into. Look at the sphere, this is the sphere.
The point is what? Point is a surface point. What is the potential due to it? Sigma by surface point, sigma by epsilon 0 into its radius. So, sigma by epsilon 0 into its radius. Similarly, for the outermost shell, this point is what? Inside point, right? Inside point potential is what? Sigma by epsilon 0 into its radius. Tell me what? Sigma by epsilon 0, sigma by epsilon 0 into its radius is C. So I take sigma by epsilon 0 common here, sigma by epsilon 0 into, what do I have? A square by B, then plus and minus together it is minus, then B, then plus C. I have three terms here. So that will give me potential at B. This is equation number 2. Similarly, I'll have what? I'll have one more term. I'll have one more point. Potential at C is to be calculated. Potential at C is what? That also has what? Three components, V1 plus V2 plus V3. So, tell me what? The outermost point. Look at this outermost point. This point is what? This point is an outside point for this shell, outside point for this shell, surface point for this shell, right? So, I'm writing due to this one. Tell me what? You know, sigma by epsilon 0 into outside point. Outside point, how do you take? Its radius square by distance. Its radius is A. So, A square by distance to that point is C. See, this distance to that point is C. Plus, second one is minus, no? Minus sigma by epsilon 0 into. What about this sphere? This sphere also has outside point here, no? Outside point is what? Sigma by epsilon 0 into its square by distance. Its radius square is how much? B is its radius, right? B square by distance is C. Look at that, that point is at a distance C. And the third one, tell me potential due to the outermost sphere. Outermost sphere, you know, it is a surface point, right? So, surface point it is what? Surface point it is sigma by epsilon 0 into its radius. Sigma by epsilon 0 into its radius is C. So, I'll take sigma by epsilon 0 common here. What do we have now? Into, this is what? A square by C plus minus together. Plus minus together it is minus. B square by C plus C. So, that is my equation number 3. So, we have answered our first part. You know, the question is to find out the potentials at A, B and C, which are the surface points of all the spheres. Now, there is a second part in which they ask you to find a relation between small letter A and small letter C. Small letter A, small letter B, small letter C. Provided potential at A is same as potential at C. So, they have given a condition here. Potential at A is same as potential at C. Okay. So, that is a condition given here. So, I'm going to put the values here. What is potential at A? I can put the potential at A. What is that? Sigma by epsilon 0 into A plus B minus C is equal to. What is potential at C? VC I have here, no? VC. Right. It is sigma by epsilon 0 into A square by C minus B square by C plus, the last point is what? Last term is what? C. So, I could cut the sigma by epsilon 0 on either side. I'll have what? A plus B minus C is equal to, if I take LCM here, it is A square minus B square. I take C here, no? That makes it C square divided by C. LCM, no? I'm cross multiplying. I get what? A into C, AC plus B into C, BC minus C into C, C square is equal to. What's the right side? Right side is A square minus B square plus C square. C square, right. I'll have identical terms on either side. Oh, right. Okay, I have identical terms. C square. No? Did I miss something? A plus B minus C. Oh, this is minus B plus C. No, minus B plus C. Sorry. Minus B plus C. This is minus B plus C. This is minus B plus C. We did a mistake there? Nothing. You know, when I rewrote it, I got the signs wrong there. Okay, nothing. This is plus minus is minus C here. This is plus C here. Okay. So, this is A minus B plus C. The right side is alright. Okay. Now that makes it this one minus and this one plus, right? I'll have C square cut. Then what? I take C common here. C into A minus B here, no? What is on the right side? I have a square minus b square, which could be written as a plus b into a minus b. A minus b gets gone with this a minus b. What do we have now? C is equal to a plus b. This is the second question. Get a relation connecting a, b, c. All right.